Hello everybody. So we are still trying to answer this question is how can we calculate or find the value of enthalpy that's used to calculate the change in enthalpy. And this question, to be able to answer this question, we already covered some concepts like the state property and non-state properties, and there are still some very basic concepts that are known to many of the audiences, but I think we need to go through them, make sure that it's clear or these concepts are clear for everybody before we proceed. So the information that we need to know is that first, the material can exist in one of three phases, either solid, liquid, or gas. This is a well-known fact, and that the existing phase depends on the conditions, mainly on temperature and pressure. So if you know the material that you are dealing with, you know the temperature, you know the pressure, you can tell if it's liquid or gas. For example, if I tell you at under the normal conditions the temperature is 25 degrees Celsius, you will know that water is liquid. If it's more than 100 degrees, you know it's a vapor, and if it's less than zero, you know it's going to be solid. This is just a very simple fact that is a known fact. And consequently, if you change the conditions of temperature and pressure, the phase can change. By changing temperature, you can melt the ice, or evaporate the water, or condense the water vapor, or freeze the liquid water. The phase transition from the solid to liquid to gas, it takes place through multiple steps. So let's say we have ice. This is what we start with, just ice. And we want to see what steps that this ice would go through in order to reach the state of water vapor. So you have solid water, solid ice, and it needs to be heated until it reaches the water vapor. So it actually happens through many steps. The first step is to convert this solid from solid at negative 10, negative 20, whatever the temperature is, it's less than zero. So we heat it until it reaches 0 degrees Celsius. At 0 degrees Celsius, it's still solid. So it's still solid at 0 degrees Celsius. But it can gain more heat to turn from solid into liquid. The transition from solid into liquid happens at constant temperature. So when you have the ice melting and turning into liquid water, this happens at 0 degrees Celsius. The temperature hasn't gone below zero or higher than 0 degrees Celsius. So this is from 0 degrees Celsius. Still at 0 degrees Celsius, there is heat lost. Gained by the ice to turn into liquid water. And then after all the ice melts, it's now liquid at 0 degrees Celsius, and then it will gain more heat. The temperature increases from 0 to 5, 10, 15, 20, and so on until it reaches liquid water at 100 degrees Celsius. Then more heat is gained, will lead to the evaporation of water. So the boiling or evaporation of water, that it's turning from liquid to vapor, exactly like what happened here. It's at constant temperature. So this happens at 100 degrees Celsius with no change in temperature. So it's liquid at 100 and ends up to be vapor at 100 degrees Celsius. If we provide more heat, then it's going to be vapor at more higher temperatures. It can be vapor at 150, at 200 degrees Celsius, whatever the temperature is. So the steps that we see are the actual steps that the ice will go through, or water will go through, starting being ice until it reaches the state of water vapor. So these are the steps that we go through for the evaporation. There are a few things that we need to know about this. That first the turning from solid to liquid is called melting, and turning from liquid to vapor is called evaporation. When we look at the heat that is gained here, we have some heat gained in this state to turn into ice at 0 degrees Celsius, heat gained for melting, heat gained for heating of the liquid, heat gained for evaporation, and heat gained for heating the steam. We would notice that there are two steps the heat doesn't result in change in temperature. In this case, the heat is leads to phase change without changing the temperature. Here we have the heat leading to phase change without changing the temperature. It starts at liquid at 100 degrees Celsius, ends as vapor at 100 degrees Celsius. Here it starts as liquid, solid at 0 Celsius, ends at liquid at 0 degrees Celsius. So since here we can see the effect of the heat that we provide, you can see the temperature increase, you can feel it, you can sense it. The same here, you can sense the temperature difference. Here you can sense the temperature difference. We call these three cases sensible heat. Sensible heat means that the heat that is gained and results in changing in temperature. You can feel the temperature that is increasing due to the gaining of heat while keeping or while the system is at the same phase. The other types of heat which result in phase change with no change in temperature, we call them the latent heat. So this is a very important thing. So the latent heat or the sensible heat that is the heat that leads to change in temperature with no change in phase. The latent heat is the heat that leads to phase change. So here it is in case it's not clear in the video. This is the one that leads to phase change. So these are two important terms, the term of sensible heat and term of latent heat. So now let's focus on this part. Just look closely at this part of the process of heating water. We said we have here liquid that is getting heated until it reaches the state of liquid at 100 degrees Celsius. Then it's heated to reach liquid at a vapor at 100 degrees Celsius, and then we heat it. This state and this state are very, very special states of water. So the first state, it's called this one, which is liquid at 100 degrees Celsius. It's called saturated liquid. And the vapor at 100 degrees Celsius is called saturated vapor. So these two terms are very, very common terms that we will be using a lot, and we use them a lot in our engineering applications. So this is a term that means a lot to us. So when we see that the liquid is, when we say that the liquid is saturated liquid, it means that it's about to evaporate. Any heat that would be gained will lead to changing the phase, will evaporate part of this liquid. The same here for the saturated vapor. It means that it's about to condense. So if we absorb heat or it loses some heat, this heat lost will lead to a changing in phase, will lead to the condensation of the liquid. So this is a very, very important term and very, very common term, the saturated liquid and saturated vapor. What the liquid that has temperatures below the saturation temperature, which is 100 degrees Celsius, or the liquid that is at temperature less than the temperature of the saturated liquid, is called subcooled liquid. The vapor that has temperature higher than the temperature of saturated vapor, it's called the superheated steam. And here it's steam because it's water, so the water vapor is called steam, so it's called superheated steam. If it's something else, it can be superheated ethanol, it can be superheated hexane, and whatever the compound that we are interested in, it's going to be called superheated. So this is the vapor that is at temperature higher than the saturation temperature. And what is between these two is called the mixed phase. So it has a coexisting phases, vapor and liquid phases. We call it a partially vaporized mixture. So one important thing that we need to know about the sensible heat and latent heat, which is a very, very important thing, that some of them are more have more value or greater value than the other. So to understand this, and especially for steam, it's a very, very important thing. If you look at this graph, we have here the specific enthalpy change that we need to heat water from 25 degrees Celsius to 100 degrees Celsius, liquid water of course, and the specific enthalpy that we need to evaporate water, 1 kilogram, of course this is kilojoule per kilogram, so this is the heat needed to evaporate or heat 1 kilogram of water from 25 Celsius to 100 Celsius. This is the heat that needs to provide for 1 kilogram of water to evaporate it from saturated liquid to saturated vapor. And this is the enthalpy change, or the heat that we need to provide for steam to heat it from 100 to 200 degrees Celsius. Of course, 1 kilogram of steam. You'd see here that the latent heat, which is the heat needed for evaporation, is way bigger than the enthalpy for heating water or heating steam. And you see here, this is 100 degrees Celsius difference, this is 75 degrees Celsius, so it's a big difference in temperature. Yet the amount of energy that we provide here and here is very small compared to this. And this is why the steam is a valuable resource, and it's part of all the chemical processes. Steam is important because we use it to store energy. So when you want to heat something, you want to store the energy in some way. We store it in steam. Steam can hold a lot of energy. It needs to take a lot of energy to evaporate. So you can store this energy, and then you can recover this energy by condensing the steam. So it loses this amount of energy when it condenses and turns into liquid after it became vapor. So steam has a very high latent heat of vaporization, and that's why we really depend on this. And in many of our calculations, we can ignore the sensible heat. And let's say you have water that you are heating from 90 degrees Celsius up to 150 degrees Celsius, for example. So there is some sensible heat to heat it from 90 to 100, and some sensible heat from 100 to 150, and the latent heat. So we usually ignore this part and this part. It's very small. You can see this value is around 2300 almost, and this is 300. So this is more than seven times the sensible heat, and more than maybe 8 times the latent heat. So this is very important information to know, that we really depend on the latent heat much more than the sensible heat. So this is the first thing that we need to know. Next time we will keep talking about the evaporation, condensation, and other factors that affect them. So see you then, inshallah. Goodbye.